So here we've got another function, and this function input and output table is given right here. So my x's are my inputs, and the y's are my outputs. Now, it's changing by different amounts between each of the y's. My x's are all going up by 1. And it wants us to find the average rate of change of y over the interval from x equals -1. So here's where x equals -1 to x equals 1. And so here you can use your same idea as getting the slope to find, well, how fast am I changing between these two different points? So I'm going to get my change in y will be on top, and I want my change in x to be on the bottom. And again, this little triangle just means change in. You can read that. Maybe I'll put a little note here. Whenever you see that triangle, you can just think of that as saying change in, and then whatever variable you've got there. So let's find that change. First, I want to find the change in y. So that's going to be my output. So you can start with either one. I'll start with this guy over here. I'm going to start with 1 minus, and then I'm going to take away that guy, -1. I got to find the difference. 1 minus -1 is going to get me 2. And now I'll just do my change in x. Well, it's the same thing. Because I started with the 1 here in the y, I've got to start with its buddy up here in the x. So I'm going to do 1 minus that -1 over there. And that's also equal to 2. So my average rate of change, the slope between these 2 points, is going to be 2 over 2. If we simplify that, my slope ends up becoming 1. That's all it is. If you want to do it for different ones, that's okay too, right? You can get the average rate of change for any function between any 2 points using that same slope formula, that same idea of just getting the change in y over the change in x. So let's try that one also as another example. So here, this time I want to do from -2 in the x, right? This is saying x is greater than or equal to -2 and less than or equal to 1. So now I'm going to do from this point that I'm coloring in black to this other point that we already started with before. Now, before we started with that, I just want to show you it's okay if you start with either one. So I'm going to start with this guy over here. Let's do that change in y first. Ooh, I mixed up the colors here. So let's start with that change in y first. I'm going to do -8 is what I'm going to start with, minus, and my other y, I'm going from x equals -2 to x equals 1. So here's the x equals -2, x equals 1. So -8 to that 1 minus 1. That's my change in y. -8 take away 1. Well, if we're not super confident with our negative signs, that's okay. I can just put in -8 minus 1. You go 1 further down, that's -9. Right? So my change in y was -9. And now let's get that change in x. So because I started with -8 over here, I've got to keep going with its buddy first over here, the -2. So I'll do -2 minus, there's that 1 over there because I'm going from my x equals 1. -2 take away 1 is going to get me -3. And so here is my average rate of change between those 2 points. It's the slope between those 2 points. Except I've got -9 divided by -3. I can simplify that. 9 divided by 3 is 3. Negative divided by a negative is a positive. So I can just leave it as +3. That's my average rate of change between those two guys. So the idea that we're getting is that this average rate of change idea, it's the same concept almost as slope, except slope, as we saw before, it only really works for finding how steep a line is. But this average rate of change lets us find how fast I'm moving in a certain point on a function that looks like this u over here, or even on a table where I don't even see a straight line. So it's really the same idea as slope, just you can use it in different contexts, more different contexts, but you use the same kind of solution, same method for finding your average rate of change of slope, and it's still basically just telling you how fast a function is moving in a certain period of time.